next session on semiconductors on 2026. Mr. Ravi Kumar from Texas Instruments will chair the session.
I'm looking very young though.
That's not my picture.
Okay. Good evening. So if you can settle down, we'll start the panel. So please occupy your seats. I'm also looking extremely young.
Is that your picture?
No.
It's not your picture.
I think they took something from the internet.
But how? No, Prashant is funny. Prashant's picture and.
You can sit on the front row.
Sure, no problem.
On the front row. Professor Rajat, can you invite everybody on stage?
So if you can kindly occupy your seats, we'll start the panel. Shall we start? All right. So I'm happy to be here as the moderator of this panel, which is going to discuss the semiconductor security viewpoint, right? And I have a wonderful panel with me. It has been a pleasure to interact with the panelists over the past few days. So I'll request my panelists to come and occupy the chairs here. Let me start with Dr. Rajat, who is from IIT Kharagpur. Dr. Rajat Chakraborty. Rajat. We have Mano from Secure IC from France. We have Dr. Shankar Reddy from Terminus Circuits. Please occupy your seats. And last but not the least, we have Prashant from Ernst & Young. Okay, without further ado, let us get started. So I am going to first say one word about myself. My name is Ravi Kumar, and presently I am with Texas Instruments, a semiconductor company, and I have been with TI for about 22 years now. And before that, I used to be a professor at IIT Delhi in the Department of Electrical Engineering. And it has been a pleasure to sort of, be part of this conference and be part of this panel. And what I'll do is I'll give you a background, right? And I will request each of my panelists to first introduce themselves and then present their viewpoint, right? So this is going to be slightly different from the previous panel. So each person will come and present their viewpoint, and then we have enough time for Q&A. I'm hoping for a very active Q&A session at the end, right? All right. So let us start with security in the area of semiconductors. See, I come from a semiconductor company. And I started hearing about semiconductor security when I started attending this international test conference. Even about 5 or 6 years ago, there were a lot of concerns about security, right? There are two aspects to that. One is the data. See, if you read the title of the panel, right, I think it alludes to how India is going to become perhaps a manufacturing hub in the near future. And as a result, we have to provide a very secure environment in which business can be conducted, right? Today, I can tell you that it is not easy to be in the semiconductor business because on a daily basis, apparently some 30,000 hacking attempts happen, 30,000 on a daily basis, right? And I'm not just saying, only TI, but across. That is the statistics available. So people are trying to sort of steal data, right? And there are a lot of stories on the internet about how people have stolen IP from other companies. People who used to work in a company when they left, they sort of stole the data, etc., etc. There are a lot of stories like that. But more importantly, there is also this ransomware, right? So today, you see, manufacturing is sort of outsourced, right? It is not that the companies are vertically integrated, right? So there was a time when design used to happen in the same company, the CAD tools were written in the same company, then the manufacturing also happened in the same company, and also testing. So everything used to happen in a vertically integrated fashion. But today it is not so, right? There are different companies all over the world which offer these services, and companies engage them. So as a result, there could be security breaches at a number of different points. So we had to worry about all these aspects. And from a semiconductor viewpoint, and I'm sure other panelists will talk about it, we are worried about how somebody can disrupt the entire semiconductor manufacturing design, and design, manufacturing, and test flow, right? See, if even if you can sort of do something to so delay the entire process, you stand to gain, right? Because there are, if a product enters the market late, that company sort of loses a big chunk of the market, right? So people have been using these kind of ransomwares to even sort of cause a temporary delay in the manufacturing process and so on. So manufacturing is apparently the weakest link in terms of this security, right? So the other aspect is the hardware security itself, right? So semiconductor that we sell, right, it is getting integrated into so many systems, and these electronic systems have to be secure, right? And today, as the panelists will tell you, there are a lot of opportunities to hack into these devices, right, through various clever means. And the people who are doing this hacking, etc., they are very seasoned, technicians. They are highly, knowledgeable about the underlying, semiconductor architecture, the semiconductor testing, how does it occur, scan chains. So they are very well versed with this. And unfortunately, we have to make sure that our semiconductors do not get hacked into, especially because now these chips are getting into once upon a time it used to be just the PC market. Later, we have the mobile phones is a big market. But now we are looking at automotives in a big way, and there are horror stories about people hacking into these cars, and taking control of the entire car. The driver loses complete control. So these are some of the possibilities that have been unearthed in the recent past. So it will be a good opportunity for us to sort of look at the perspectives from all the panelists, and understand from them what are some of the threats that they see, and what are some of the solutions that they see in the near future, and what are some opportunities. See, whenever there are challenges, there are also opportunities. So we may also be able to unearth some opportunities. And also maybe there is a lot of thing to say about practical issues, right? As a practitioner, see, if you join any company today, I think TI included, one of the things that they will train you on is this security aspect, right? So we should not become the weakest link by compromising the security of the entire company, right? And today there are a lot of people who are trying to use social media to design this sort of social engineering attacks, phishing mails, etc. So as a result, training is also a very important aspect. People have to be very aware of what these crimes are, and what is the price that we pay for it. So I'm sure the panel will also talk a little bit about from a practitioner's viewpoint, right? So I think that is where I'm going to stop, and let me first introduce Let me first invite Dr. Rajat Chakraborty, Rajat Shubhra Chakraborty, who is in the Department of Computer Science at IIT Kharagpur, to sort of get this panel started.
Okay, thank you, Dr. Ravi Kumar, for the nice start and for introducing us. So, just in brief, my name is Rajat Shubhra Chakraborty. I'm a full professor in the Computer Science and Engineering Department at IIT Kharagpur, and currently I'm the Associate Dean of Engineering. So I primarily have worked in academic research, academia since 2010, but I've also have had intermittent experience of working in corporate R&D, particularly recently I was in Intel. Yeah. So, so I would today I just as part of my a part of the portion that I'm going to cover, I'll concentrate on the global trends of semiconductor manufacturing. I think Dr. Ravi Kumar also touched upon it briefly. The current trends of semiconductor manufacturing is horizontal, and you find that it is highly specialized in a few countries, as is shown here, particularly in East Asia. Okay, and Taiwan alone manufactures approximately 50% of the total global semiconductor manufacturing. There is extremely limited number of specialized suppliers globally for raw materials, fabrication equipment, and EDA CAD software. Particularly fabrication equipment, you might be knowing about a company called ASML based in Holland, which is essentially currently probably the only company that can manufacture equipments for the most cutting edge technology nodes like 7 nanometer or 3 nanometer. So that's quite unbelievable, right? I mean, you have one of the foundational technologies that is driving the world today, and there is only one company that can make equipments which are used to manufacture them. Okay, the biggest threat, in my opinion, is something which is outside technological purviews and outside the control of technologists like us. And that's the geopolitical tension that is playing out currently. We directly do not have any control on that, and unfortunately, it adversely affects the industry in a big way. Okay, so say for suddenly, if tomorrow Taiwan gets cut off from the semiconductor supply chain, what would happen, right? We are not ready for it. The world is not ready for it. Forget about India. The world, as you see, is mostly like if you look at the map, mostly are these gray portions, okay? Interestingly, many of these countries probably had semiconductor manufacturing at some point in the past, but no longer they do that, right? So there are also issues that many companies have kind of closed down their fabs in many countries because those are no longer cost effective, okay? So we envisage that there will be grave supply chain disruptions, both globally and selectively in a few countries. Okay, material, equipment, software, human resource, everything might get affected, okay? So human resource, for example, in Intel, when I was working last year, once the Ukraine-Russia war started, Intel overnight closed down their corporate office in Russia, okay? So that human resource, some very, very talented people, I mean, I knew a few of them, completely got cut off from the company overnight. So that's a disruption to the company, but there is nothing you can do about it. So the big issue is this trustability that comes along with this. I will focus more deeply on this trustability issue on this slide. So what this shows is a very well-known diagram, or trust level diagram, that was proposed in a call for proposals in 2007 by DARPA. It has several color-coded portions. The green ones, steps are completely trustable. The yellow ones can be either trustable or untrustable. The red ones are completely untrustable, which means you have the least control over them. Okay, why are these things untrustable? Just like Dr. Ravi Kumar mentioned, that in a horizontal business model, you no longer develop everything that you need to make a modern IC or a SoC in-house. You take the best CAD tools, you take the best hardware intellectual property blocks, you take standard cells libraries. Okay, you do whatever you need from other third-party vendors which provide you more cost-effective solutions, and then try to design it using a distributed team of engineers all over the world. Okay, and then it is probably sent out to an offshore fab. And other than some very few companies, most large companies are fabless nowadays. Probably Intel is probably the only exception, and maybe some in the memory semiconductor sector. Okay, interestingly, one very interesting aspect of this is you will find that the design stage itself has been shown in yellow, which means that you can't even trust the design and validation process that is happening in-house. Okay, so you get all the building blocks, you get all the CAD tools, and you build your chip, and you can't even trust your own team of designers. So the situation is that grave. And there are two reasons for it. One is there might be the bad guy in your team which is doing it, and the other might be the designs have become so complex. Okay, the bad guy's task has become probably easier, because like I just seeing on Wikipedia, currently the M2, say the M2 Ultra microprocessor from Apple has 134 billion transistors. Okay, it's currently in 2023 the microprocessor with the largest number of transistors. So when you try to validate them, okay, formal verification is probably not that advanced to do a full chip SoC validation. You essentially do a simulation-based or random test vector-based validation, which is of course not perfect. So every phase of the semiconductor manufacturing is vulnerable. Testing, the package and testing step was thought to be, at least DARPA thought it to be trustable, but later on, and even actually research even before that has shown that that's not trustable, especially if you have DFT type techniques, scan chains, etc. in your design, then those can be utilized to leak secret information like cryptographic keys from secured ICs. So there can be bugs in the software. In the CAD software also, there can be bugs. You can validate a CAD software, complex CAD software. In the design, incomplete validation, given the complexity of the designs, the intellectual property modules can be stolen. Okay, counterfeiting and overproduction of ICs in the fabs might happen globally. I mean, in a remote fab, you have no control over it. Of course, you can't really have a look at what is happening in a remote fab. And there is an estimate, I mean, that is one of my research areas, detection of counterfeit integrated circuits. Current estimate that at least, and this is a lower estimate, that at least 30% of ICs currently in circulation worldwide are counterfeit. Counterfeit means either they are counterfeit with respect to the producer, like say it is being sold as a IC from company XYZ, but it's actually not from company XYZ, somewhere else. Or it is being reused. So this is being recycled IC. It was earlier part of some PCB from which it has been extracted, maybe polished to make it look new, and then it is being sold in the market. So that's quite scary. Next, I'd like to draw, or let's just ponder over how to face this menace. I mean, what to do. So there are several techniques have been proposed. The split manufacturing is, I would say, probably not a very popular technique as of now. So what the idea is that you do the transistor level and the lower metal levels at an untrusted high-end foundry, and then you do the higher metal layers at a trusted foundry. So you have to then transfer the stuff to the other. So there are big logistical issues regarding this. And as far as I know, it's not very widely accepted. Domestic production of silicon ICs is fundamentally a requirement. Okay, I mean, this is something which India have been pondering over for many, many years. We have to decrease any country which is completely dependent on imported electronic components, especially integrated circuits, have to eventually decrease that dependence. Okay, and it must span all steps. This is also very important. So currently, probably some initial efforts have started where packaging and testing and assembly, etc. operations are going to start in Gujarat, maybe in other states also. However, we need fundamental wafer fabrication and actually IC fabrication. Okay, that thing is needed. That is still not there. And that will also probably stop IP piracy and counterfeiting, because you have much better control over the fabs if they are inside your own country. Volume is a big issue in India, okay? So India alone will be about 64 billion US dollar semiconductor market in 2026, okay? So can you manufacture everything, given that 2026 is 3 years away from us? Everything in India, even if we start now, can we scale up to that volume? Probably not, right? So that fundamental problem would still remain. Okay. So there have been some efforts from the government, because I primarily work with my research has been funded historically primarily from the government, different funding agencies. There are declared policies for several sectors, like telecom and power sector. I currently have projects from this power sector, power ministry, which to deal with secure IC design, etc. There are policies that any equipment that you deploy in these sectors have to be certified to be secure, okay? They can be certified to be secure, not counterfeit, etc. However, that's a very difficult thing to do, technically, because most of them come as a black box, and you won't be able to read the firmware, and also you won't have any idea of the individual ICs that are there inside that black box, okay? Even if you somehow had access to the individual ICs, just fully validating an individual IC or an SoC nowadays, given the complexity of their designs, is quite formidable. So we need big technological advancements. It's a very rich and open research area, a lot of unanswered challenges. From an academic research perspective, there is a lot of scope to work on. That's why I'm excited. I have been working on this for the last over a decade and a half, since my PhDs. And not everything, all the problems have been solved, but slowly we are having solutions which probably would be useful in the near future and would prove really valuable. I think one of them is physically unclonable function, or PUF. It's a major area of my research also, which we will be having one of the panelists cover. So that's it from my side. Maybe I'll just hand over to the next one.
Thanks a lot, Rajat. Let us now request Mano to talk about hardware security.
Thank you so much. So I'll talk also about the future of semiconductor security. So I'll first go to the upcoming semiconductor challenges, then move to the hardware security, which is at the core of the industries, and finally speak about potential solutions. So a bit about my person. So I am a sales manager, Southeast Asia, for a French company called SecurIC. So I studied Asian studies and international law at LMU in Munich, Germany. I studied cross-border management at Oxford University. And concerning my working experience, so I've been a political advisor at the European Parliament. I worked as the strategy analyst in the automotive sector for BMW. Also worked as a sales in the civil nuclear engineering. And so now in the cybersecurity solutions for embedded systems. So what are the upcoming challenges in terms of security? So on the first hand, technological. On the second hand, geopolitical. So first, the post-quantum cryptography, PQC. So the asymmetric encryption vulnerable to PQC cryptoanalysis. And so this is a topic that we have been studying already before the NIST, but basically this American agency is setting some standards, and she is providing some efforts. So to make sure that all systems and equipment are PQC ready for 2033. So we only have 10 years to do this. So we really must start now to update our algorithm to make sure it's resisting quantum computers, right? And this has to be applied to all kinds of governments around the world. And then my second point is about the artificial intelligence. So it is having advanced computing capabilities. And on the one side, we see that it has enhanced security intelligence, whereas on the other side, well, attacks are becoming more performant. Yes, it requires also a lot of resources, such as data storage or computing performances. So this is, I believe, a huge challenge because this technology is able to learn by itself quite quickly. So we need to be there and respond to this challenge. And my third point is about the need for lifecycle management of security, which means like the devices needs to be to stay up to date in terms of security from beginning to the end. So, yeah, big challenge. And then geopolitically, so yeah, Professor Rajat just mentioned it. The increasing tensions between the USA and China is not making it easy for this semiconductor industry. We've seen lots of bans of technologies, as well as sovereignty issues, right? So we need to ensure trust throughout the entire supply chain because, yeah, hardware Trojans, my colleague Katik held a beautiful speech about it yesterday on how to detect it. Also mentioned by Professor the continuous supply of chips. COVID-19 has been a big issue for that. R&Ds, and we've seen many CHIPS Acts in the USA, in Europe, and so I believe that there is a real need for Asian countries now to find partners that are independent, so not necessarily US or China, but I believe that Europe is an alternative partner. We are neutral, and for example, yeah, I think you've seen Modi and Macron meeting each other, so for me it's really the starting point of a long-term friendship between our countries. And yeah, it's, for me at least, and for the company, a proof of trust, right? So, yes, and also, yeah, so France is willing to support India throughout different markets. And of course, we are neutral because we are able to work with the USA, but we are also able to work with China. So we know how to handle this kind of situationships and how to handle confidentiality as well. So, for example, I mean, we've been working with French ministers as well. Yes. So, the third point would be also the protection of the intellectual property. So, we have found that more of half of the companies has been enduring some security violation in the 2 last years. This is a huge amount of companies. And we really need to input on more security to avoid this, because this leads to some terrible decrease in company valorization, 25 to 50%, depending on which country, which market. So, yeah. So, the hardware is, security is really at core of the industries. So we have two driving industry, which is automotive and defense and space. So concerning autonomous driving, smart mobility, more than 80 ECUs is in these modern vehicles, which obviously increases the risk of remote attacks. Also of having some backdoors, and also while the updates are made. So this is also a risk when it's sent to the cloud. So also the management of the fleet vehicle over time must be carried. So the FOTA, so the firmware update over the air, the alerts monitoring, and a V2X to make sure that any kind of device the vehicle is communicating with is secure as well. And then coming to the defense and space, well, we all know it's really kind of industry where you require the highest level of security protection against SCA and FIA, tampering attacks, and hardware Trojans. So data security need to be encrypted end-to-end. So for PQC, authentication, AI-based protections analysis. Yeah, we really need to build a root of trust for both of these industries. It's really important to have like embedded security solutions following the current standards. So here you see a few ones that I think everyone knows. Yes. So what kind of solutions can be found for these emerging technologies? So just to give you a short explanation, so this is our root of trust. But security challenges is different according different markets. And so through the entire design, the life cycle of this device, and I think PQC begins and AI as well. And so we need a support from the industry, which brings a concrete solution on the market, right? And to make sure there is security along the entire life cycle of the devices. So, yes. And very quickly, so these are our solutions. I will not expand more right now, but if you want, you can come to me and talk. We have a booth over there. Yeah, the message I think I want to give is that India really need a trusted partner to become more independent. I've heard this last day so much about Make in India. I believe this is possible, and that India maybe needs some supports because this is huge issue coming. No one can handle this by itself, and I'm looking forward cooperation that are more international. Yeah, to make sure solutions are compliant. So thank you. I'll give back the word.
Thank you. So thanks, Mano. And now we have Dr. Shankar Reddy.
Yeah, hi. This is Shankar Reddy from Terminal Circuits. I think it's not written anyway. That's my fault. Hi, this is Shankar Reddy from Terminal Circuits, and I did my graduation from it has come from IIT Kharagpur and post-graduation, and after that I did my PhD at Indian Institute of Science. And later I was with the industry and then also as a faculty member at IISc for 15 years before moving to the industry. So I did work in different companies like Sasken, IBM, and after that I started my own company in 2010, Terminal Circuits, which is basically into high-speed interface IPs. And along the roadmap, while we are doing different designs and all that, we got some awards and all that. I'm not going to dwell on that. So this today's topic is, I was trying to give the explanation or the concept of physically unclonable functional devices, which are sort of hardware devices for security aspects. So if you see PUF, we call it as physically unclonable functional devices. There are different aspects that we can be using for PUFs for the security aspects. Some of the devices may need very high-end security and some may be needed for weak security, and for applications it can be standalone in the sense it can be add-on or it can be integrated into the applications devices. And physical contents and also from the point of source of variation. At this point of time, I'm not going to touch upon source of variation. Source of variation will come mostly from the point of manufacturing part of it. And the more relevant for the today's topic is on semiconductors. I'll be talking about in the semiconductors which are into physical content part of it, which is electronic and non-electronics portion of it. So I am going to work on or talk about the electronics portion of it. So there are two which can be done in hardware side of PUFs in the electronics portion of it, which can be implemented either digital way as well as mixed signal way. Why, if it can be done in digital way, why we need to bring in mixed signal way? Digital way is somehow it is called as weak from the point of PUF. But in adding mixed signal into that will be make more safer. So in the electronic components, there are two variants of puff devices. One is memory-based one, and another is non-memory-based one. A non-memory based one, it is propagation delays, what we talk about, buffer circuits and all that, where the delays can be used as a signature for the particular system to connect or disconnect. And coating part of it is basically this is a passive device in which number of capacitors can be added and make it is more tough from the point of decoding. Voltage drop also is from the point of the devices with the IR drops. And then radio frequency part of it, which is basically done for out of band. Out of band in the sense if, for example, in wireless communications, if the main transaction of wireless is happening in the particular band, so this handshaking will happen with a different band, which will be apart from that main band which used for wireless transfer data. So this is the one which we call it as out-of-band security aspect that can be used for handshaking to connect to the device. And talking about most of the things that are being done is memory-based ones. In the case of memory-based ones, there are bistable and monostable. And now with quantum cryptography, so it is coming multi-stable memories. So for example, if I take the bistable one, if I take 4-bit, maybe 16 responses can be there for that, or 16 combinations can be there. But if I take one bit or one qubit with 8 stable resolutions, then it can be 8 into 8 to the power of 4. Instead of 16, it will be 1024. But it can be, as you keep on increasing, it will be much, much more, and it is very difficult to decode it. So when you're talking about for different applications, what type of security that can be there as a hardware part of it, is the level of security that is needed from the point of challenge response pair. Challenge is nothing but inputs that we are giving. Response is nothing but the number of combinations that functionally it can make. And the other one is on-chip or standalone. That by definition it is on-chip or standalone we can make out. And the other one is digital or analog. As I said, we want to make it foolproof completely. It is better to have analog way of implementation. And also from the point of number of bits and implementation, as you increase the number of bits, the complexity will go up, and also it may increase the safetiness of the device, but only thing is it will not be cost effective. From the point of location of the device, because from the point of servers and all other systems, it will be secured place, these devices will be there or servers will be there, whereas for IoT devices, they will be scattered all over and will not be having any hold on the place, and also the security is not that sure. And the type of anticipated threats. So application specifics, if you want to make it from the point of computers, where my processors, HPs and all that, the ways of pseudo-random bit generation, or the store devices like fingerprints and face recognition can be used. And I did talk about out-of-the-band for management. And from the point of storage devices, these can be considered as online and as well as offline. Online is the one in which directly connected to the internet or the devices. Offline is the one like USBs, which you can take from one place to other place. So in case of IoT devices, it can be ring oscillator, SRAM, or arbitrator-based and capacitor that is passive coating based. For data transfer, that is like when you are using Ethernet or also connecting to the online and all that, this, any of these combinations can be used based on the requirement. So let's take a specific case on IoT devices. The nature of the IoT devices, they are located in uncontrolled locations, and also the type of attacks that can be theft or tampering, as well as the reverse engineering that can happen. And by nature, they will not be having a lot of storage in the IoT devices, and also it will not be having any processing or energy resources. So vulnerability for the SRAM type of security devices will be high in these cases. And primitive and also the non-existing operating systems for IoT devices, because they are all tiny in nature. So the best suited for them is SRAM-based puff, also the configurable ring oscillator-based puff, and also capacitor-based puff and DRAM puffs. So these are the things that can be used based on the complexity and the security you are looking for, and also also from the point of its expensive and different scenarios that may be required. This is a glimpse of different devices that I talked about for IoT from the point of different aspects like criteria, and you can see impact as well as time to respond, and also from the point of extra fabrication steps. So extra fabrication steps in IC engineering is going to cost more, and also the metastability potential, large volume response, or large number response. Large number response is nothing but where you can use it, more number of bits that can be used from the point of making it more and more tougher from the point of decrypting it. So the hardware security will be added layer, which is more foolproof from the point of thefts or decrypting part of it, because it generates more number of devices which are not certain from the point of actual devices. Like in the case of bits that we are going to use it as a digital portion of it, it always can be decrypted. Because nowadays with the technology, as we get into more and more technology, also will get more into more risk. For example, if you are using any of the aspects of encrypting, decryption things can be made or modeled using the AI or machine learning process part of it. Coming to the semiconductor roadmap part of for India, at this point of time, Government of India is supporting a lot of chips that can be made inside India. Either we use our fabrication, maybe distinct it is as of now. But even if the fabrication is done at outside India, so how we are going to make encoding, decoding locally, either as standalone systems or as integrated systems, that can be talked of. And because of the encouragement, and a lot of companies are trying it out to make the devices on their own with fabless companies, like RISC-V processor-based ones are MCUs, and also telecom chips for 5G and beyond, and then storage devices like SSDs and other things, and also network cards like network on chip, as well as many other devices that can be going into the network part of it, and IoT devices for sensor networks and wireless sensor networks. There are two aspects of it. One is standalone aspect. When you are making, these devices can be made at different places. And these standalone aspects that are being done can be used for large volume productions like ASICs, which can be sold worldwide, as well as can be used inside India for secure our ICs. And these are the ones which can be there from the point of supply chain management as one of the components which can be there as a security component. For example, in case if it is integrated one, which is going into the silicon, then we can license these IPs for those who are manufacturing the RISC processors or MCUs or different applications that comes in India. That's all from my side. Thank you very much.
Thanks, Rajat. So in this conference, I think many of you are, working very closely with in the areas of security, and you may be, doing research, etc. But there is also a sort of practical aspect about security, and I request Prashant to sort of talk about that.
Thank you. I hope this one is working. Am I audible? Yeah. So thank you, and I think it's been such a pleasure to listen about semiconductor and its future and the security from, I would say, one of the best experts in the country and of course world over. So what I'll do is I'll try to summarize the state of the nation when it comes to the semiconductor security, and I'll also try to bring in the practitioner's perspective in the whole thing. So my background is I'm an engineer, MBA from IIM Mumbai. It used to be called NITI Mumbai, and I'm a partner with EY, and I run the cybersecurity business for global financial services clients. So if we focus and if we take a 30,000 view on the semiconductor industry, the first issue which comes to our mind is shortage. I don't think security is an overwhelming issue in terms of regular people's mind or users' mind. Try book a car today, and the delivery lead time is what? 6 months, 1 year, 1.5 years? Key equipment, even medical equipment, is just not available because there is a massive shortage. While there is so much effort which is happening to take care of this shortage, but what happens is when you're racing to address the shortage issue, you are going ahead for production, you're going ahead for volume, and then like any other initiative, security becomes an afterthought. The second problem which is coming in this is, if we are able to breach into semiconductor security, there is a disproportionate return of investments. There is a case study available or example available, and I am not saying that this is a true or it actually happened. But let me quote what Bloomberg said, and later on it gave a addendum as well. So mid 2020, Amazon and Apple, they were using a specific set of computers, and the deployment was more than 30,000 servers at each one of them. I'm approximating the numbers. And after quite a few years or months of sustained usage, they realized that the base chip has been compromised or tampered. And when they started, and they actually figured out, not through chip testing or a procurement testing, because when we are buying servers as an organization, I don't think anybody is going to go and look into the chip security. I'll come to it in a minute. So when they looked at it, they saw abnormal traffic pattern originating from these servers, going to some destination which was not a regular destination. So the cyber tools and the security operation SOC center, they picked it up. And then like everybody, when you can't figure out what it is, you start blaming a nation state. Later on, both Apple and Amazon, they issued I would say, soft denial. Homeland Security was slightly, I don't know what was their stance. And later on, Bloomberg came out with some addendum saying that, well, this happened, but this didn't really happen. So this is just one of the cases of semiconductor security. And it just tells us that as corporates, how vulnerable we are to a semiconductor security issue. Now, coming to the point that if semiconductor security more often than not becomes a nation state issue, because the return is disproportionate. If you can compromise a popular chip which is used, let's say, I think there was a reference to autonomous cars or autonomous vehicles. If you can compromise into one of those chips, and it takes a lot of art of the fancy technology, a lot of PhD experts to compromise the chip. But if you are able to do that, and if you are able to compromise the supply chain, then you are very much able to get your chip implanted into as many devices as possible, and then you wait. You wait when there is a strategic reason to activate it. But naturally, if you look at it, when there is a cyber stockpiling happening at a nation-state level, I think it's anybody's guess that which all countries will actually be stockpiling with respect to their attack weaponry, even on semiconductors. The next issue which comes in is how difficult it is to secure the entire supply chain. Because I think the experts, all of them, they mentioned about how, if you look at the entire supply chain process, so there is a design, and then there is a manufacturing, and even manufacturing is not a simple in-house, one-shop manufacturing. It is like a distributed manufacturing, and then it gets assembled. And then later on, there's another level of assembly of the chips. Then it gets packaged into some device. Then the device gets shipped to the end user for consumption. Now, if you look at the attack vectors, there is a total possibility to compromise it at the design level itself. Then there is a possibility to compromise it at the fabrication level. And of course, that's the most difficult one, because of late there is a distributed fabrication happening. But still a sophisticated technology can still be leveraged to do some tampering at the fabrication level. And then after that, when it is assembled into the device, let's say we are buying a TV or we are buying a server, and even at the assembly level, there is a tampering. In that case, you don't replace the chip, you just put an add-on hardware module, or you just try to mess with the circuitry of the chip. And then last but not the least is it can still be compromised at the consumption level. So for example, if I'm using a computer, somebody can still run a side channel attack to figure out the passwords and the encryption and the cryptography which I'm using. So if you look at it, the entire supply chain is absolutely vulnerable. It has not been exploited at scale because this is sophisticated, high-end engineering skills which is required. Now, there is another threat which is coming in, and I think Manu referred to it about quantum computing, and with so much of quantum progress which is coming in, and I think you mentioned a threshold of 10 years, and before that, we just need to evolve the chip design itself to a significantly next level of security. Otherwise, the chip security itself gets broken. Uh, Having said that, well, it's not all that doom and gloom. If you ask me today, what is the best defense? I think the best defense is that we are common people. Nobody comes after common people. But the challenge is very serious for nation state, and it is also very serious for Fortune 1000 or Fortune 2000 organizations. Uh, Coming from a practitioner's lens, I don't think most of the companies in their cybersecurity function, we think about chip security or a semiconductor security. We focus on buying, let's say, Intel or wherever we are buying from, but we are assuming that the device is shipped secure. I've rarely or hardly seen any of these cyber functions which actually go and test the semiconductor security itself, even for critical devices. And not to forget the proliferation of IoT. And IoTs are sitting duck. Forget the security, the functionality itself is a big question mark. And with billions, if not trillions of IoT devices which are supposed to show up everywhere, I think we are really vulnerable when it comes to IoT security and the IoT chip security. So yeah, quite a sombering realization, but I'm sure with all of you guys and experts like this, we should be able to figure out a way ahead. And one last comment, I think there are a lot of seats vacant, but if you guys really want to make a career in cyber, I think chip security is a field which I'm sure will be an upcoming field. Thank you.
So thanks, Prashant.
Now we open the floor for any questions. Does anyone have any questions? Okay.
So maybe I will begin with some questions so that we warm up, and maybe some audience also will ask some questions. So actually, I think Prashant mentioned that these Fortune 500 companies, they are at the highest risk, and also the nation state is at the highest risk. Fortune 500 companies may also be able to protect themselves with some security measures. But, what about smaller companies, right? The semiconductor industry is not, though there may be one large company like Texas Instruments or Intel, but they rely on so many smaller companies for IPs, for test services, and so many different things. So what about, then won't there be a, security getting compromised, even though they are... Okay. You want to say something? Yeah. Yes.
No, I think, yeah, you bring a very interesting perspective that it's not just big companies, even smaller companies can be a target. And also agree with your point that big companies still have some budget to secure themselves.
Yeah, and I think what I've heard is the ransomware attacks are the highest on smaller companies because they are not able to, protect themselves as well as, the larger companies. The spending is very high on security, right? The other question I have is for Dr. Rajat. Rajat, the other aspect I have heard a lot in, when I attend the International Test Conference or VLSI Test Symposium, this is a hot topic there. See, there is a lot of fake chips that are getting produced. I think some of you may know this. See, for the same reason that we mentioned earlier, see, the manufacturing is outsourced, right? A lot of manufacturing is outsourced. A lot of design is outsourced. So as a result, somewhere somebody could, steal your design, right, and come up with what looks exactly like the original, right, but it's a fake, right? And the problem with that is when one of these chips fails in the in a user product, unfortunately the customer is going to contact the company which produced the original chip, right? They don't know that it's a fake. So it's a headache for the semiconductor company because they have to first check whether it is a product that they actually produced, right? So I want to know from either Rajat or Shankar, what is some research that is happening to identify which are fake chips and which are not?
Yeah, thanks, Dr. Ravi Kumar. So there are several techniques that can be used. Some of them are techniques which can be applied on any IC without any circuit level modification. For example, I have worked on techniques where for particular types of fake ICs, by performing image processing application, I mean taking an image of the surface and analyzing the texture, you can figure out whether this is a fake or an authentic image. The University of Florida in the US have a big lab called FIX Lab, which specializes in counterfeit integrated circuit detection and counterfeit PCB detection. They have very advanced equipment, including X-rays and other things, to even like basically industrial grade X-rays to look beyond the packaging and analyze those things. The other approach which personally, because I work on that topic, which I would personally kind of go for is something based on physically unclonable function that the panelist was mentioning. That is a good foolproof way of ensuring that every integrated circuit that is manufactured has a particular signature, and you can tag the signature with its serial number or some standard identifier, keep it in your database, and later on if the question arises whether this is a fake IC or an authentic IC, you can always get back to the company which marketed it and say that, well, can you consult that database and tell me whether this is a fake or an authentic IC. Given that physically unclonable functions by definition will have a different signature for every instance, it is more or less certain that you will get a definitive answer whether this is a fake or authentic IC. The problem is that PUFs have slowly started getting into mainstream designs like FPGAs, SoCs. All Intel SoCs from maybe 2025 onwards are going to have on-chip PUFs. Many Intel FPGAs have it, many AMD, that Xilinx FPGAs have it. Many other ICs also have it. You can buy the PUF intellectual property modules from companies and then integrate it with the rest of your circuit. But still, it's not that widely known and it's still not that popular. However, I believe that in the years to come, PUF is going to be a circuit level foolproof solution to this problem. That's my hope.
I think we have had a very good panel, and I would like to continue this for a little bit more time, but organizers are telling me that we are already behind time, and therefore we would like to close. But before I close, I would like to extend a big thank you to all the panelists who have spent their valuable time to be here and prepare and share their ideas with you. So let us give our panelists a big hand. And of course, I would like to thank the organizers. Many organizers were also involved in helping us with the panelists, and in particular Teja. Let us give a big hand to Teja. So thank you very much, and you have been a very good audience. I thank you also. Thank you.